Bismillahirrahmanirrahim. Rabbi shrah sadri wa yassir li amri wahlul 'uqdatan min lisani yafqahu qawli. In the name of Allah, the most beneficial and merciful. Uh, my lecture today is on super elevation attainment, and as you all know, I am Professor Adnan Qadir. We need to understand how super elevation is attained gradually on a highway. Look at this diagram. Uh, Before the start of the curve, that is BC, we have the super elevation. At here, it was a normal crown of 2%. And at the start of the curve, we have a adverse crown or negative crown of plus 2%. And at the end, we have a fully super elevated crown, that is 5%. What I mean to say is that whenever we have to provide super elevation, we start not at the start of the curve, but much before the commencement of the curve. And, transforming from the normal crown, that is minus 2% or minus 1.5%, to our expected or our designed super elevation, we have what we call a super elevation transition. This distance has two segments. One is what we call a crown runoff or what we call a tangent runoff, and the other is the super elevation runoff. This crown runoff, in that distance between this point to this point, we will change our negative slope minus 2% to 0%. I mean the outer shape, and will not do anything with the inner edge, that is still minus 2%. Now, at some distance, that is I will change from 0% to 2%. That is what I've done is I've changed minus 2% to plus 2%. At this point, this is at the start of the curve, and the distance from 0% slope needed for doing that from 0% to plus 2% is known as 2/3 of the length of super elevation runoff. And after the remaining 1/3 L is we just do it the full super elevation, that may be 5% or 8%, whatever is given to or what is our desired super elevation. Now, in order to understand fully, let's try to solve one example. Now, take a look at this data. We had a sample data in which we had a radius of 500 meters. We have a design speed of 90 kilometers per hour. Our curve station is 2290.60. Our end of the curve is at 2520. The width of our lane was 3.65 meter. And I'm talking about only one lane. We may have 3 lanes or 2 lanes, that obviously beyond the scope of this lecture. Then we have the normal crown value, a normal value, the slope value given for draining out of the water. And normally it varies from 1.5% to 2.5%. In this sample, I have taken as minus 2% or simply minus 0.02. Now let's calculate. We must know what is the super elevation. Super elevation we can calculate from this formula, that is what I mean to say, from E maximum V square over 127 R. Now, we must understand that this is the formula that is different from the conventional formula in which we write R minimum equal to V square of over 127 E plus F. And this is a practical formula that says that we will use this equation for calculating maximum super elevation. Now, practically, we do not take, we can say that E maximum compensate 75% of the design speed. So in this formula, instead of taking 90 kilometers per hour, we'll take 75% of 90 kilometers per hour. So that's why our E maximum, if you calculate, you are not calculate design E maximum from 90 kilometers per hour, but from 75%, that is 67.5 kilometers per hour. So that's how you get the value